Welcome to Knowledge Panel. If you've ever shivered through a brutal winter, you've probably heard the term polar vortex tossed around. It sounds dramatic, like an Arctic cyclone swooping down to freeze us all, but the reality is more nuanced and fascinating than the headlines suggest. The polar vortex has become a catch-all explanation for cold snaps, but it's often misunderstood. Today, we'll dive into the science, bust 3 big myths, and show how the polar vortex really shapes our winter weather. By the end, you'll know what it is, what it isn't, and how it actually affects you. Let's get started. Let's tackle the first myth head-on, that a polar vortex wobble guarantees a deep freeze for North America or Europe. It's a claim that pops up every winter, especially when temperatures start to drop and headlines get dramatic. But is it really that simple? Let's dig into what's actually happening high above our heads, and why the story is much more nuanced than it first appears. The news loves dramatic animations, and those swirling blue and purple forecast maps that make it look like an icy apocalypse is on the way. It's easy to see why. These visuals grab attention and make for great TV, but the reality behind these graphics is far more complex, and the science doesn't always match the hype. The event that often triggers this so-called wobble is known as sudden stratospheric warming, or SSW. This is when the stratosphere, an atmospheric layer sitting about 10 to 50 kilometers above the pole, suddenly heats up, sometimes by a staggering 50 degrees Celsius in just a few days. It's a dramatic shift, and it can set off a chain reaction in the atmosphere below. This rapid warming disrupts the stable, spinning polar vortex, a vast, swirling mass of cold air that usually sits locked over the Arctic. Imagine the polar vortex as a spinning top. When it's stable, it keeps cold air bottled up at the pole. But when SSW hits, it's like someone bumping that top, making it wobble, tilt, or even split apart. When the vortex is strong and stable, it acts like a barrier, keeping the frigid air contained. But when it's disrupted, the vortex can weaken, wobble, or even break into pieces. This can allow cold Arctic air to spill southward, sometimes plunging into North America, Europe, or Asia, and bringing with it those infamous cold snaps. That's why SSW events are often linked to cold snaps in the news. But here's the crucial point. It's all about probability, not certainty. Just because the vortex is disturbed doesn't mean your city is destined for a deep freeze. It simply means the odds of a cold outbreak have gone up. Think of it like rolling dice. A disturbed vortex loads the dice in favor of cold weather, but it doesn't guarantee you'll roll a 6. Sometimes, the cold air stays put, or it heads somewhere else entirely. The atmosphere is a chaotic system, and there are many moving parts. It's a bit like eating junk food. Indulging in a bag of chips or a slice of cake raises your risk of a heart attack over time. But it doesn't mean you'll have one tomorrow. The risk is higher, but the outcome isn't set in stone. The same goes for a polar vortex wobble. It increases the risk of a cold snap, but doesn't make it inevitable. The atmosphere is incredibly complex. Where the cold air actually ends up depends on a whole host of factors: the path of the jet stream, the position of high and low pressure systems, and even the temperature of the oceans. All these elements interact in ways that are difficult to predict with absolute certainty. Sometimes, the displaced cold air targets Siberia, the North Atlantic, or even East Asia, leaving North America or Europe relatively untouched. Other times, it's your backyard that gets hit with the brunt of the chill. It's a global game of atmospheric roulette. So when you hear about a polar vortex disruption on the news, it's a signal to pay attention to the forecast in the coming weeks. Not a reason to panic or assume a deep freeze is guaranteed. Meteorologists will be watching the models closely to see where the cold air might go. Meteorologists know that the risk of a cold snap is higher after a vortex disruption, but it's never a done deal. They use sophisticated models and years of experience to make the best predictions possible, but even then, surprises can happen. Think of the polar vortex wobble as just the first domino in a long chain. For a deep freeze to hit your area, many other dominoes, like the jet stream, pressure systems, and local weather patterns, have to fall in just the right way. Sometimes they do, and sometimes they don't. So, myth 1? Busted. A polar vortex wobble stacks the deck in favor of a cold snap, but it doesn't guarantee one. The next time you see those dramatic headlines, remember the atmosphere is full of surprises, and nothing is certain until it actually happens. Now let's move on to the second myth about the polar vortex, one that's surprisingly common, even among people who follow the weather closely. The myth goes like this: all polar vortex disruptions are basically the same. If you've heard about a sudden stratospheric warming, or SSW, you might picture it as a single dramatic event that always leads to the same kind of wild winter weather. It's easy to imagine the polar vortex as a giant switch in the sky. Either it's on and everything's normal, or it's off, and chaos reigns. But in reality, the way the polar vortex gets disrupted can play out in very different ways, and those differences matter a lot. Meteorologists actually classify SSW impacts into two main types: displacement events and split events. Each has its own signature and each can affect the weather in unique ways. In a displacement event, the polar vortex is pushed away from its usual spot over the North Pole. It's like nudging a spinning top so it wobbles off center, but doesn't break apart. The vortex stays mostly whole, but it's no longer sitting neatly over the pole. When this happens, the coldest air gets funneled into one or two regions, depending on where the vortex is displaced. For example, if it shifts toward Eurasia, countries like Russia and parts of Europe can get slammed with a deep freeze, while places like North America might actually experience milder conditions for a while. The other type is called a split event. Here the polar vortex doesn't just move, it actually breaks into two or more smaller vortices. Imagine that spinning top shattering into pieces, each one spinning off in a different direction. When the vortex splits, those smaller pieces can wander over different continents, bringing frigid air and stormy weather to multiple regions at the same time. This can mean that North America, Europe, and Asia all get hit with severe winter weather, sometimes for weeks on end. The aftermath of a split event is often more dramatic and longer lasting than a displacement. The cold can linger for a month or more with repeated waves of snow and ice, while a displacement event might only bring a couple of weeks of harsh weather before things return to normal. When meteorologists see the signs of an SSW developing, their first big question isn't just will there be a disruption, but what kind of disruption is it going to be? That's because the type of event, displacement or split, can completely change the forecast for millions of people. To make things even trickier, different weather models can predict different outcomes. Some might show a displacement, others a split, and sometimes the models disagree right up until the event actually happens. This adds a layer of uncertainty that makes forecasting these events a real challenge. That's why, after an SSW, you'll often hear meteorologists talk about a range of possible impacts. They're not just hedging their bets, they're reflecting the real complexity of the atmosphere and the different ways a polar vortex disruption can unfold. So, the idea that all disruptions are the same just doesn't hold up. The style of disruption, whether it's a displacement or split, determines who gets hit, how severe the weather will be, and how long it will last. That's why understanding the difference is so important, and why Myth 2 is officially busted. Myth 3 is a persistent one, that a disruption in the polar vortex locks in a cold, snowy winter for months on end, sealing our fate as soon as it happens. This idea has become especially popular in recent years, with headlines warning of polar vortex collapses and months of deep freeze after a sudden stratospheric warming or SSW event. It's easy to see why this belief sticks around. After all, when a big SSW hits early in the season, it often brings a memorable blast of cold and snow. Neighborhoods dig out from heavy drifts, and it can feel like winter will never end. But is that really the case? The truth is, the atmosphere has a surprisingly short memory. Weather patterns are constantly shifting, and what happens in the stratosphere doesn't always dictate what happens at the surface for months at a time. After a disruption, the polar vortex doesn't just stay broken. Instead, it begins a process of recovery. The swirling winds, high above the Arctic, start to reorganize, gradually piecing themselves back together. As the stratosphere cools down again, the temperature contrast between the pole and the mid-latitudes returns. This contrast is what powers the vortex, allowing it to re-strengthen and regain its grip on the upper atmosphere. The speed of this recovery depends on the type of disruption. If the vortex is displaced, it can bounce back fairly quickly. If it splits into two or more pieces, the process takes longer. But even after a major split, the most significant impacts on our weather usually last only 4 to 6 weeks, not the entire winter. That's just a fraction of the season. Timing is everything. If a disruption happens early, there's plenty of winter left for the vortex to recover and for milder patterns to return. An early season SSW can certainly shake things up, but the atmosphere is resilient. The vortex has time to rebuild, and the weather can shift back toward normal or even milder conditions as the weeks go by. On the other hand, a midwinter SSW, when the vortex is at its strongest, can unleash the most dramatic, cold snaps. These are the events that make headlines, with temperatures plunging and snow piling up in a matter of days. But as spring approaches, the sun climbs higher in the sky, and the vortex naturally weakens. Late-season SSWs have less impact, because the stratosphere is already preparing for the transition to summer. So, one disruption doesn't lock in a season of cold. The atmosphere is always in motion, breaking free from any single event's grip. Weather is dynamic, shaped by countless factors: ocean currents, jet streams, and even distant volcanic eruptions. The polar vortex is just one piece of a much larger puzzle. That's why meteorologists keep a close eye on the vortex's recovery, always watching for new disruptions and changes in the broader climate system. The idea that a single polar vortex wobble can lock in winter's outcome is just too simple. The reality is far more complex, and far more interesting. Myth 3. Busted. The polar vortex isn't a mythical Arctic hurricane. It's a normal, permanent part of our atmosphere. When it's disturbed, the drama is real, but it's all about probabilities, not guarantees. A wobble doesn't guarantee a deep freeze. Not all wobbles are the same, and one disruption doesn't lock in the rest of winter. Understanding these nuances helps us be smarter about weather news. Next time you hear polar vortex, you'll know what's really going on. If you love digging into the science behind the headlines, subscribe to Knowledge Panel. Thanks for watching. See you next time.